Today we will discuss about EIGRP, Enhanced Interior Gateway Routing Protocol. Like other protocol, for example RIP, which basically rely on the hop count basically. For example, here hop count is 1, here hop count is 2, here hop count is higher, but still it will choose this path. This is a serial cable and serial connections are very slow, but still it will take this path to reach here from here. So that is a problem with the distance vector protocols which rely on the hop. So we need to enhance it. That's why EIGRP was introduced by Cisco. So enhanced distance vector protocol like enhanced interior gateway routing protocols EIGRP include other path attribute to make path selection besides hop count. Those attributes are advertised from neighbor to neighbor for each prefix. For example, here it will try to take this path, router R7 to R2 to R1, then R3. It doesn't rely on the hop count because it will simply avoid the serial cable because serial connections are low. So it will calculate basically, and on the base of calculation, it will select the path. Now, what are the base of calculations? We will see in our lab as well. So now if we talk about enhanced distance vector protocol, here one example is given. For example, packet want to go from router 3 to router 7. So which path it is choosing? It is choosing this path, router 3, router 1, router 2, and then R7. So this is the path it is choosing. So enhanced distance vector protocol like enhanced interior gateway protocols include other path attributes to make path selection besides hop count. Those attributes are advertised from neighbor to neighbor for each prefix. Logic includes backup path for faster convergence. Okay, so it also takes some backup path as well, so that if primary path fails, it will go to the secondary path. Now in EIGRP, so the EIG process is associated to an autonomous system. So in lab we will see, we will give the autonomous system. A router can run multiple EIGRP process. For example, in this AS number 100, we can see the 3 routers, and AS number 200, we can see 2 routers. So here we have R1, R2, R3, and R4. Here we have R5 and R6. So by default, from AS100 to AS200, the routes will not be exchanged. So we need to do some redistribution. We'll discuss about in our advanced topics. So how EIGRP communicates? It basically, as you can see, EIGRP run directly over IP using its own protocol 88, and EIGRP use multicast address 224.0010 or this type of MAC address when possible, and unicast packets are used when necessary. So this is some important point of EIGRP. Now 5 type of you can say message exchange. So EIGRP uses 5 different packet type to communicate with other routers. First of all, update. Now this packet is used to transmit routing and reachability information with other EIGRP. Then request, used to get specific information from one or more neighbor. So this is used to transmit routing and reachability information, and this is used to get the information from neighbor routers. Query, send out to search for another path during convergence. For example, one path fails, so it will also try to reach by another path. Reply, sent in response to query packet. For example, if it received query packet, then it will reply. And finally, hello packet, used for EIGRP neighbors and detecting when a neighbor is not when a neighbor is no longer available. So it will use basically hello packets. So EIGRP communication is based on router ID. Okay, now this router ID is 32-bit number that uniquely identify a EIGRP router. So what is router ID? The EIGRP router ID is 32-bit number that is uniquely identified as an EIGRP router. So router ID is basically identification of a router in the system. RID typically represent IPv4 address that resides on the router, such as loopback address. So we can give loopback address because loopback address never go down. Any IPv4 address can be used, including the IP address not configured on the router. So why it says basically we should not use the IP which is configured on the router as router ID, because interface may go down but loopback will not go down. iOS dynamically allocates highest IP address of the up loopback. For example, you have 1.1.1.1 and then you have 2.2.2.2. So by default, it will take 2.2.2.2 as a router ID. If there are no loopback interfaces, highest IP address of active physical interface become router ID when the EIGRP process initialized. But it is not recommended. You should have the loopback address because it will not go down. EIGRP neighbors. EIGRP does not rely on periodic advertisement of all network prefixes in an autonomous system, which is done with routing protocols such as RIP, OSPF, and ISIs. So it will not periodically, it means periodically send the advertisement continuously to each other, between neighbors like RIP or OSPF or ISIS. EIGRP neighbors changed the entire routing table when forming an adjacency and advertise only incremental update as topology changes occur within the network. So if any new route is added, then incremental update will go. It will not exchange the whole routing table because it wants to save CPU and RAM as well. Now EIGRP neighbor adjacency process. So EIGRP requires neighbor relationship to form routes are processed and added to the routing information base RIB. The following parameter must match for two router to become neighbor. So metric formula K values, you can simply search on Google and you will be able to find what is K values. Primary subnet matches, it means the subnet should match. It is not possible here you will use different subnet and here it will use different subnet. ASN number match, and if you are using authentication parameter, that should also match. So these two router will do what? So first of all, these two routers give this kind of packet: update packet, request packet, query packet, reply packet, and hello packet as well. So these packets are basically sent uh, in the process of creating neighbor basically. So update, request, query, reply, and hello packet. So these packet are used basically. So this is the process of EIGRP, how EIGRP maintain the you can say our routing information base and also exchange the incremental route with each other. Now in next lab we will learn more about other protocols and we will do practical as well.